and begin the session. So, welcome everyone to today's session of multi-cloud happenings. We're so glad that you've joined us and will spend some time with us today. We have a lot of really exciting information to share, and we didn't want to spoil it with teasers other than that it has to do with the Exadata Database Service on Exascale infrastructure, as well as the base database service in multi-cloud. With that said, the time is now, so let's get started. Please use the Q&A function to post questions at any time, and we'll do our best to answer them as we go, and we'll save time at the end of the session to answer questions live. Some quick introductions. My name is Nathan Fuzzi, and I'm a product manager here at Oracle, where I work on the Exadata Database Service and the base database service, both in Oracle Cloud and in the multi-cloud space. I'm joined by my colleague and good friend, Vishal Patil. Vishal, would you like to introduce yourself?
Sure. Thanks, Nathan. Hello, everyone. My name is Vishal Patil. I'm a product manager for Exadata Database Service, Base Database Service, and Multi-Cloud Solutions.
All right, thanks, Vishal.
Mhm.
So here's our safe harbor statement. It effectively says that we're sharing information and we may discuss future plans, and anything that we say here is for informational purposes only and should not be taken as a commitment to deliver anything specific or on any specific timeline. And statements made here may not be incorporated into a contract. And we do encourage you to reach out to your account team if you have specific requirements for more concrete plans or timelines for anything discussed. Now let's set some context for the discussion ahead. So over the past decade, Oracle has expanded its on-premises database offering to the cloud via Oracle Cloud Infrastructure Public Regions, Cloud at Customer, and OCI dedicated regions. In the past several years, Oracle has also built and announced partnerships with other leading hyperscalers, including Microsoft Azure, Google Cloud, and most recently, AWS, which now offers Oracle Database at AWS in general availability since July. Oracle's multi-cloud philosophy is to bring the Oracle database services to where you operate other aspects of your infrastructure and make your most critical business data available to all the services in your preferred cloud provider, including AI, ML, and analytics services. This simplifies your architecture and improves performance and scalability while also providing all of the Oracle database capabilities, security, and reliability that customers have long used on premises. So, what services are available in Oracle's multi-cloud offering? Oracle Autonomous Database is our most advanced, fully managed cloud-native database offering running on top of Oracle Exadata. The Exadata Database Service delivers an Oracle database service on the Exadata platform with extensive cloud automation while leaving full administrative control in your hands. The base database service offers a lower cost Oracle database service on standard infrastructure, and there think virtual machines with attached block storage that still gives a lot of cloud automation and also still gives you full administrative control. And finally, the autonomous recovery service gives you a fully managed zero data loss backup and recovery solution that minimizes the impact of backups to your database, stores them efficiently, and provides continuous validation of your backups for peace of mind. All right, now that we're all on the same page with regard to the multi-cloud concept and the services offered, let's talk about what's new. First, we launched the Exadata Database Service on Exascale infrastructure on Oracle Database at Google Cloud this month. Well, what is Exascale? Exascale is the next generation data intelligent platform that combines Oracle Exadata hardware and software intelligence with the scalability and pay for use benefits and economics of the cloud. Now, with this month's launch, Exadata Exascale infrastructure is now available in OCI, Azure, and Google Cloud. The Exadata Database Service offers two types of infrastructure in the public cloud: dedicated infrastructure and exascale infrastructure. Both types run on Exadata, and both offer a scalable platform that's designed to service mission-critical database workloads. Dedicated infrastructure offers tenant isolation by means of hardware that is dedicated to a single customer. And this makes it suitable for workloads that, one, require that kind of isolation, but also as well as a consolidation platform for hosting potentially hundreds or thousands of databases. With dedicated infrastructure, you provision the infrastructure itself, including compute and storage servers, and then you place VM clusters on top of that infrastructure where you then create and run your databases. Exascale infrastructure abstracts away the hardware provisioning, and you need only to provision your VM cluster. Oracle handles the placement of your cluster and allocated storage across a pool of resources, allowing you to provision as little as a single VM cluster with 8 eCPUs and 300 gigabytes of Exadata storage. From there, you can scale your deployment as needed while always benefiting from Exadata performance and other characteristics. A little more on the scaling capabilities of Exadata Exascale infrastructure: you can provision as little as a single VM cluster, that is, a cluster of only one virtual machine. Now, does that give you the same high availability as a multi-node cluster? No, as there's no way to run Oracle RAC on a single VM. But it does still give the other benefits of Exadata, including extreme I/O processing capabilities, smart scan, flash cache, and others for workloads that don't require HA. But more importantly, scaling the infrastructure from one VM to two or all the way out to a 10 node VM cluster is a simple cluster modification API call or a few clicks in the console. Scaling back in is just as straightforward. And the database storage capacity can easily scale from that 300 gigabytes smallest allocation up to 100 terabytes per exascale vault. So you can get an idea of the granularity of scaling of both the compute and storage in Exascale, allowing you to pay only for the resources your workload needs. So what differentiates Exascale infrastructure? Well, of course, it's the power of the Exadata platform with its inherent performance, reliability, availability, and security. Exascale brings the entry cost for Exadata characteristics way down so that it can be effectively used for much smaller database workloads, while also giving granular pay-per-use cost control to right-size the solution to your workload. Running on a pool of shared resources allows Exascale to scale in and out as your workload demands, without having to reserve capacity ahead of time or pay for unused resources. Exascale also helps to boost developer productivity with the ability to provision thin clones as needed to give any developer or team their own environment that still benefits from all Exadata features. Now let's look at the architecture of Exadata Exascale infrastructure. The two main components are the compute cloud and the storage cloud, which are decoupled so that you can scale either one independently of the other while still maintaining high bandwidth, low latency connections between the VMs in your cluster and between the VM cluster and the Exascale storage vault. Oracle takes care of VM placement across the physical servers. So you need only to specify the number and size of VMs in the cluster, the VM storage to be provisioned, and the capacity of database storage in your Exascale vault. Note that Exascale infrastructure places your VM storage on the Exascale storage cloud as well, rather than within the server where it's actively running, meaning that the VM's storage is not coupled to any particular compute server. This makes restarting the VM on a different physical server a trivial operation in the event of a database server failure or a scaling event. Exascale takes care of data striping and mirroring for availability and provides a single logical container for storing all database files, reducing the potential for space that can get stranded in more segmented configurations, like separate mount points for data files and backups, or multiple ASM disk groups. Multiple VM clusters can even share an Exascale vault, increasing storage efficiency and providing additional options for moving databases or sharing thin clones across VM clusters. Exascale infrastructure also provides a cost-effective mechanism for your VM to scale up and down without a reboot. With Exascale, you can allocate both enabled eCPUs as well as reserved eCPUs. With reserved eCPUs, you pay for the reserved compute infrastructure capacity, but you don't need to license the eCPUs while they're not enabled. Enabling reserved eCPUs is a simple VM cluster modification that happens completely online. And you can scale up or down as needed to serve your database workload adequately while also optimizing your license costs. And since memory in Exascale is allocated by the total eCPU count, you get the benefit of additional memory tied to your reserved eCPUs all the time, whether those eCPUs are enabled or in the reserved state. Increasing or decreasing the total eCPUs or memory available to the VM cluster simply requires a rolling reboot. Another major benefit of Exascale infrastructure is the ability to create intelligent thin clones of your PDBs. Of course, you can create a full thick copy of your PDB, but Exascale enables you to quickly create thin clones from a live PDB or a snapshot, whether in the same CDB, another CDB in your VM cluster, or across VM clusters. There's no read-only test master required, so creating the thin clone is very fast and space efficient. And the cloning process leverages redirect on write technology, making source PDB and clone PDB maintenance both space efficient and IO operations efficient. And best of all, the clones get native Exadata performance and other features just like the source PDB. We've also introduced snapshots, which capture a point-in-time view of a PDB. You can snapshot a PDB at any time to preserve the image of the data for as long as you need. You might take a snapshot so that you can see what the data looked like just before a large application deployment, or as a restore point to potentially undo database changes, or to use as a source for multiple clones of a PDB from exactly the same point in time. Because the snapshots are lightweight and only consume space as source data changes, you can take and retain potentially many snapshots and even create multiple thin clones from any snapshot to provide each developer with their own writable copy of the source database, again, with all native Exadata features. One last point on Exascale infrastructure. The management model here illustrates that Oracle owns and manages all the hardware, physical networking, monitoring and maintenance, as well as the hypervisor layer. You, as the customer, are responsible for provisioning your VM cluster, CDBs, and PDBs using cloud automation that and can even install and manage additional software on your VM. This model creates a clear separation of both management responsibilities as well as access boundaries. You alone control access to your VMs and thus to your data. Okay, the next major announcement this month is the general availability of Oracle Database 19c support on the Exadata Database Service on Exascale infrastructure on both Oracle Database at Google Cloud and Oracle Database at Azure. This one is extremely exciting as it offers a way for customers running Oracle Database 19c to migrate to and run on the Exadata Database Service on Exascale infrastructure without a forced upgrade in OCI and in two major partner hyperscalers. Now, this launched about a week back in Google Cloud and is launching imminently in Azure. So let's look deeper into this functionality. And to see how Oracle Database 19c is supported on Exascale infrastructure, it's helpful to show the existing architecture and the new side by side. So on the left, we have an Oracle Database 23 AI Exascale VM cluster. Exascale natively supports Oracle Database 23 AI with all Exadata features and optimizations, including the ability to store all database files for all databases in the VM cluster in a single Exascale storage vault. With its tight integration with Oracle Database 23 AI, Exascale does not need to run ASM on the database compute nodes, freeing up those resources and further decoupling the compute tier from the storage tier. In order to run Oracle Database 19c, the VM cluster must use a 19c compatible Exascale storage vault, which presents Exascale block storage to the VM cluster, which then uses Oracle ASM to define disk groups in the vault for data, log, and recovery objects. Exascale still manages striping and mirroring of the data, so you will see the ASM redundancy for these disk groups as external. The 19c databases you then create, and both CDB architecture and non-CDB architecture are supported here. They still benefit from automatic data tiering across XRMM, flash cache, and hard drives, and they still benefit from RDMA to the storage servers, delivering huge amounts of IOPS and bandwidth at low latency. What does this look like? Well, here's a snapshot of the Google Cloud Console showing the specification of the Exascale storage type to be used for our new VM cluster. Note that selecting 19c for the grid infrastructure release will force selection of Exadata block storage for the VM cluster. It is possible to run Oracle 23 AI grid infrastructure on Exascale block storage, although, as we've seen, this requires running ASM on the database compute nodes, and it splits the Exascale vault into separate disk groups, which creates additional partitions of your space that don't add value for Oracle Database 23 AI. To get the full benefits of Exascale infrastructure for Oracle Database 23 AI, we recommend using Exascale Smart Storage Vaults for 23 AI databases. And now I'll turn the mic over to Vishal to talk about additional launches. Vishal?
All right, thank you, Nathan. Let's look at some of the recent announcements around base database service for multi-cloud that includes Oracle Database at Azure and Oracle Database at Google Cloud. Next slide. Now, base database service is a full-featured Oracle Database Cloud instance offering flexible virtual machine shapes on shared compute and block storage. It supports both Oracle Database 19c and the latest version of Oracle Database 23 AI, and is available in both OCI and multi-cloud environments. Now, you maintain complete administrative control while eliminating infrastructure management responsibility and boosting productivity with cloud automation for provisioning, backup, scaling operations, and even disaster recovery. Now, the service also delivers compelling cloud economics. You benefit from low pay-as-you-go pricing, independent compute and storage scaling operations, and the choice of license included options, and we'll talk about those, or bring your own license as well. Next slide. We've had base database service in Oracle's public cloud, that is OCI, and we are excited to inform you that base database service is generally available in our multi-cloud cloud services partners such as Microsoft Azure and Google Cloud. In multi-cloud, base database service is offered on standard x86 shape, which is generation agnostic. What that means is Oracle manages the underlying hardware transitions for it. Base database service, it's an additional service as part of the offerings we have through Oracle Database at Azure and Oracle Database at Google Cloud. These services run natively in Azure and Google Cloud data centers, which allows you to have lower latency connectivity from your applications running in respective clouds. As I said earlier, it offers both 19C and 23 AI Oracle database versions. Also offers options such as Data Guard, and you can back up your databases to autonomous recovery service. And these options allow you to design for high availability and disaster recovery. The slide lists some of the specifications for Oracle-based database, Oracle's based database service standard x86 shape in multi-cloud. It offers, as you can see, the license included editions such as standard enterprise and enterprise high performance. We'll see more details about what that means. And it also allows bring your own license as well. Next slide. Now, just to reiterate, the underlying infrastructure is owned and managed by Oracle, including the hypervisor. You will create and have full administrative control over the virtual machines. And you can use the cloud automation through the console or APIs or SDKs to create, update, backup, scale up, scale down operations, or change the compute shapes. Those kind of operations, you can use the cloud automation, which is available with this service. Next slide. All right, so this is these are the licensing tiers I was talking about earlier. In multi-cloud specifically, you have 3 license included tiers to choose from based on your workload requirements. You can have standard, which includes machine learning, spatial and graph, and up to 3 PDBs you can create. So one container database can have up to 3 pluggable databases in the standard edition. Next is enterprise, which includes data guard, real application testing, and some of the newest features such as true cache. Then there is enterprise edition high performance, which includes everything from the enterprise database service and provides features such as partitioning, advanced compression, multi-tenant, security options such as label security and database vault. And all of these tiers come with the tablespace encryption through the transparent data encryption. Now, for bring your own license, you can use transparent data encryption, real application testing, data safe, then the management packs, the diagnostic and tuning packs, data masking and subsetting packs without any additional cost. All right, next slide. Okay, now let's look at overall architecture for base database service in multi-cloud. To start with Oracle Database at Google Cloud. As you can see, the base database service runs natively within Google Cloud's data centers, along with other services such as Exadata Database Service, Autonomous Database, Autonomous Recovery Service. Now, these are part of all these services are part of Oracle Database at Google Cloud offering, which provides low latency connectivity from your applications running in Google Cloud's data centers. Now, there is a new construct within Google, which facilitates the networking architecture. It's called ODB network that provides connectivity between Oracle Database at Google Cloud resources in the OCI child site, which is in the Google's data center, and your Google Cloud VPC network. The ODB network maps OCI network resources such as the virtual cloud networks VCNs and their related subnets back to Google Cloud. Now, as you can see on the picture, the control plane on the right side, it is in the parent OCI region, which helps Oracle to manage the infrastructure through the high bandwidth OCI managed network between Google's data centers and OCI data centers. You can utilize other OCI services such as object storage or OCI Vault, etc. Next slide. Now, likewise, for Oracle Database at Azure, we have OCI child site in Azure data centers, while control plane resides in OCI's parent region. As you can see on the picture on the right side, the OCI parent region is shown on the left side. In the Azure data centers, you'll see the OCI child site. We have services such as Exadata Database Service, Base Database Service, Autonomous Database, and Autonomous Recovery Service natively running in Azure data centers. Now, these different services will help cater different requirements for your Oracle workloads. Now, one important thing to note here is that there are two new constructs known as resource anchors and network anchors. To logically group resources and map them to OCI, these are created. And this is the requirement for running base database service in Oracle Database at Azure. So we'll look at them quickly to understand what resource anchor is and what network anchor is. Next slide. Okay, so resource anchor is used to group resources and map to OCI compartments. As the diagram shows, resource on the left side, if you see resource anchor RA1 in Azure is mapped to compartment 1 underscore RA1 in OCI. Now, whenever the resource anchor is created, it creates an OCI compartment to ensure one-to-one mapping. Think of this as having a resource organization between Azure and OCI to facilitate the grouping of logical grouping of the resources within Azure ecosystem. Next slide. Now, similar to resource anchor, what we have is network anchors, and they are used to map the networking resources, such as VNets or subnets. Now, these resources from Azure to the OCI network resources. Now, for an example, VNets from Azure to OCI VCNs, virtual cloud networks. In the picture, you can see network anchor NA1, which is in resource anchor RA1, is linked to OCI VCN in linked compartment 1 underscore RA1. So you can also see mapping between delegated subnet in Azure's VNet and client subnet in OCI VCN. Just to reiterate that the resource anchor and network anchor, these constructs are required for base database service in Oracle Database at Azure. All right, next slide. Okay, so you can find more information about all of these services. We have CSP-specific cloud services, partner-specific documentation on OCI. So you can access these links here. We will have this deck ready, and you can access these links from the deck. But then there is one link at the top, if you see, which lists the multi-cloud region and capabilities, where you can see wherever these services are available, what all services are available for each of the CSPs, and then find more information about the region availability and those kind of stuff. Next slide. Okay, I'm very happy to share that Nathan and I will be at Oracle AI World this year in Las Vegas, October 13 to 16, where we are presenting on this topic titled Best Practices for Oracle Database Strategies in Multi-Cloud Solutions. If you are attending AI World, please join us for this session, which is LRN 3495. Looking forward to meet some of you there. Next slide. All right, and if you need more information or have any questions about any of the services we mentioned today, and then other services which are part of the multi-cloud solution offering, please scan the QR code to join us on Slack, or you can type the URL which is listed there, and we will be there to help answer some of the questions you have or discuss your requirements. All right, with that, we are at the end of the presentation. Let's see if we have any outstanding questions.
Awesome. Thanks, Vishal. So we did have one question that came through in in a private chat. So the question was just, what is the underlying hardware for the base database service in multi-cloud? And the answer is that this is standard OCI compute and storage infrastructure. There was a follow-up question asking whether it was the ODA or the Oracle Database Appliance, and that's not the case. It's really just standard compute and storage infrastructure for base DB.
That's right.
Um, and there were a couple of questions which I answered uh, via the Q&A function, but I think it's worth covering those right now as well. One question was, isn't extreme performance, including rack, available on Azure and GCP? And this applies to the base database service. And the answer is no. The extreme performance option is not available in the multi-cloud offerings. So at currently Azure and Google Cloud. If your workload requires Oracle RAC, we would recommend that you consider the Exadata Database Service, either on dedicated infrastructure or Exascale infrastructure, or run Oracle Autonomous Databases for those workloads. Again, that applies to the multi-cloud offering of base database service. And another question was whether standard edition is restricted to 8 OCPUs or 32 eCPUs. Again, this applies to the base database service, and that number is correct. It is up to 32 eCPUs for base DB standard edition.
Right.
Let's see. Are there other questions, Vishal?
I don't see anything unanswered there. There is a question, how is it getting located in OD at Azure? Um, so in OD at Azure or in OD at Google Cloud, how is it running? Still not clear in OCI. It's OCI compute, but what for multi-cloud? So the underlying hardware, it's a general purpose hardware used in multi-cloud environments as well. It's a standard x86 shape, which is created to help customers who are running in other CSPs. And that what we are doing through this standard x86 shape, which is available in OCI as well, is we are making sure that the hardware transitions which happen underneath are transparent to the user base.
Great. Thanks, Vishal. Let's see. I'm not seeing. Oh, maybe there is one other question, and I lost it.
Yeah, so Joe is asking, do you plan to introduce extreme
Oh,
flash storage type for Exadata in ODB at hyperscalers? At this moment, I don't have any ETA for that, but I'm sure if this is a customer requirement, we are working on it. So that's what I can say.
yeah, that's a good point, Vishal. If you have customers who need that, we encourage you to reach out to us or your Oracle account team or your other cloud partners to communicate that requirement so that we can fully understand it. Any other questions? All right. Looks things like things are pretty quiet. Thank you so much
Yeah.
for joining us. We really appreciate it. It was great to have you, and we look forward to future sessions.
All right. Thank you, everyone.